Okay, here's Tylenol. This is acetaminophen, and I want to talk about how it can be synthesized from phenol. So phenol is this molecule here, where you have an OH group dangling off the aromatic ring. And when you do electrophilic aromatic substitution of phenols, substitution at the two ortho positions or the para position can occur. And so to install a nitrogen at the para position, you would need to use nitric acid and sulfuric acid, and this would install the nitro group. Now from here, you would reduce this using iron and hydrochloric acid, or HCl, and this would give you the amine, okay, or the aniline functional group. And the aniline functional group can then be acylated with many different ways, but we could use acetic anhydride, much like how we did with aspirin in the previous video. So that's how you could make acetaminophen. Now, there's a use of this when you're dealing with amines. Now, say for example we want to do a nitration of this aniline. Okay, this would give you unintended results. Either the chemical reaction wouldn't work, or it would give you the wrong product mixture. Now, normally nitrogen is a strong electron donating group, and we would expect substitution at the two ortho groups or the para position, and we want to get, let's say for example, para-nitroaniline. Okay, and what happens instead is that, remember that amines are basic. And what would occur here is that the aniline would pick up an H plus from either the sulfuric acid or the nitric acid to give you the protonated aniline. And this does two things. This converts the aniline into an electron withdrawing group, because there's no longer a lone pair on that nitrogen. And now this becomes a meta-director, okay? So this becomes less reactive and it has the wrong directivity or orientation. So yeah, that's not going to work. So what we need to do when we're dealing with anilines is do the following sequence. Take aniline, acetylate it with acetic anhydride, and what this does is reduces the reactivity slightly, but it's still, because of the lone pairs here on the nitrogen, it's still an orthopara director. And what we can do is treat this with nitric acid, sulfuric acid, and that would, for example, if we want the para, that would give us para-nitro acetamide, phenyl acetamide. So that right there is not quite what we want, right? We want this molecule up here. So to get that, what we have to do is deprotect this acyl group. And we do that with water, acid, lots of heat. Okay? And that will be hydrolysis. Okay? So we've talked about amide formation here. Amides can be formed from acid chlorides, two equivalents of an amine of your choosing, We could also use acetic anhydride. And this would give us the same product. Okay. Those are the two main ways to make amides. There really aren't any other good ways in your sophomore organic chemistry textbook. Now, reactions of amides, there are quite a few. We've talked about hydrolysis of amides. And what we do is we add water, acid, lots of heat, and this takes a while. But this gives us, after workup and all of that, the two separated molecules, okay, of acetic acid and aniline. How does this work? The mechanism involves protonation in the acid conditions. So P for protonation. The phenyl ring is just a bystander in all of this. So we once again always want to choose to protonate the carbonyl carbon. Now here's where water can come in as a neutral nucleophile and attack the carbonyl carbon to give us this guy here. Now, we've got to do some manipulations and so on to kick off the leaving group. So remember, again, we want to get free aniline, so we got to kick off this guy here. So we need to remove a proton from the oxygen and deliver it to the nitrogen. And generally that does not happen in an intramolecular fashion. Normally you have a water molecule serving as a product solvent, a proton donor, or a proton acceptor. So first we deprotonate. Okay, and then we can protonate the amine. And now either of these two oxygen atoms have a lone pair and can kick off the aniline product. And we form a protonated acetic acid. Now, these are acids, right? And these are bases. So under the acidic conditions, the aniline product that you first form is more than likely in the protonated form. Okay, so what you get here are, because we have lots of acid and water and heat right as the reaction conditions, we probably will get acetic acid and aniline as the reaction products. But you could then subsequently work this up with a mild base and, do workup. So that right there is a deprotonation, however you want to look at it. So that's PAD-PED once again for the reaction mechanism. Okay, so again, amides are very unreactive substances, but we have first protonation, and that triggers attack of water, proton transfers, we eliminate aniline, and then there's this acid-base reaction at the end. So that's the hydrolysis of amides. Proteins, for example, from beans or meat, from our diet, contain polymers of amino acids. And these R groups are the side chains of the different, amino acids. And when this goes into stomach acid, right, with some enzymes, trypsin and chymotrypsin and other things, there's going to be a hydrolysis here. The body cannot use acid and heat, large high amounts of heat and refluxing water, with water, but there is hydrolysis to give you smaller amino acids, smaller polypeptides, and these can be absorbed through the linings of the intestine to serve as, food sources, to synthesize other things. Okay, so that's a little bit about how to synthesize Tylenol, how to acylate the nitrogens of anilines, for example, or other aromatic derivatives to serve as protecting groups so that you'll get the correct reaction. Another, I'll just squeeze it in here, reason that we would want to protect the nitrogen is because, remember, this nitrogen with the lone pair is so coordinating. If we try to do a Friedel-Crafts acylation, this nitrogen will attack the aluminum, inactivating the catalyst and causing it to be an electron withdrawing group, and there's all these problems, right? So what we would have to do is first we would have to acylate this molecule with acetic anhydride, then do the Friedel-Crafts, then step 3, do the hydrolysis, which requires water, acid, very patient amounts of time when you heat this up. And this would give us the methyl group at the ortho and the para position. Okay, so that's a protection in step 1 and a deprotection in step 3. And you just have to do that kind of lengthy process to avoid side reactions of the aniline. Okay, amides can be formed in a couple different ways. They can be hydrolyzed, and I'll talk about a couple of their other reactions in the next video.